All right, so those of you playing at home, it is the 29th of September, almost October. Next week it will be. And we're going to talk about percent error. Before I go too far, I want to be very clear with this. If you want to know where you stand with homework, I printed a report yesterday that went up until 6.4, and a lot of us still needed to do 6.4. If you are not done with your assignments, you will not be taking the mastery. Now, sometimes if you're like a little low on one or two of them, but you've done them, you've practiced the skills, you just didn't get all the way up to 80%, sometimes I'll let that slide. But if you have assignments completely missing, you are not taking the mastery. And this is not trying to tell you like, ooh, I could get out of the mastery. That would be great. That's not what I mean. Because if you don't take the mastery tomorrow, you're going to be doing your homework while you sit here and waste the time that you should be taking the mastery. So then, next week, once you've completed the homework, during AO or extensions, you will need to take the mastery still here with a teacher. So if you're in AO when I'm not, like I'm teaching, you would need to I will give the other teachers the test and they would need to watch you take the test because you can't use any other materials. So my advice, get your work done. Because I would prefer that we all take the mastery tomorrow. That would be the best idea. What was your question going to be? Yeah, tomorrow. Mastery, Chapter 6, Friday. By the way, before I move too far, there was a question from the Chapter 5 Mastery. It was question 9. I'm actually going to drag my smartboard thing down to talk about it really quick. It involved a squared plus b squared. How many people remember the question I'm talking about? Chapter 5 Mastery. It said, find the value for a squared plus b squared when it gave you two different options. The first one said when a is, and I might be switching them around, and the second one flipped around which one was negative. Actually, then I think a was just positive 5 and b was negative 8. And I think the issue that we got into here was that your calculator is stupid. Your calculator is stupid. What is squaring a number? What happens when we square a number? Like if I say a squared, what is that? Colin? Multiplying a number by itself. So if I have negative 5 squared, if I have negative 5 squared, it's going to be negative 5 times negative 5. Now, Hayden, do you know what a negative times a negative is going to give me? A positive, right? So when I look at negative 5 squared plus 8 squared, that becomes 25 plus 64. Neither of these is negative. The errors that I saw are people trusted their calculator. You need to have your brain engaged anytime you're using technology because you cannot blindly trust technology. Because if I type in negative 5 squared, what's my answer, Xavier? Is that right? No. Because the calculator is following the order of operations. It does the exponent before it looks at the negative. Now, I can fix that mistake by typing it into my calculator as that. Because then it sees I'm squaring the quantity negative 5. But if I type it in like this, it's going to square the 5 and then make it negative. So be very careful as you're doing, because you need to do those Chapter 5 corrections before, they have to be turned in with the Progressing to Mastery. So reminder, if you need a Progressing to Mastery, please pick one up. That's also a great option if you take this Chapter 6 Mastery tomorrow and hopefully get done with it with time to spare. You can work on the Progressing to Mastery. Abby?
Also, when you use the calculator, you can't do negative 5 without the parentheses, because even when you do that, it'll say syntax error.
That's because you probably accidentally used the minus instead of the negative.
Oh, yeah.
So pay attention that there is the minus and then there's the negative. They're in two different locations. So here on the poster, minus versus negative. The thing in the parentheses is the negative. And depending on your calculator, Depends on how good it actually does it. But the Texas Instruments, they rigidly follow the order of operations, which can sometimes get you in trouble if you don't type things incorrectly. So, did anybody, out of sheer awesomeness, complete any more of this table? I think where we landed yesterday had that this was 0.75, which became... We didn't fill that in?
Yeah, we did.
Yeah, so those of you that don't have it, you just put your notes away too early yesterday. We talked about how this, if I like unreduce it, essentially, becomes 75 over 100, which gives me my 75 hundredths, which becomes my 75%. Because to go from decimal to percent, and you might want to notate this on your paper, we are just multiplying by 100. I get it. You have a PDF. I see you. What's up, Mr. Sherg? You want to learn about percents?
Nope.
So, my second... You're coming back.
If this room is 78 degrees and that room is 67 degrees, what percentage higher?
What percent error?
Or what percent, what is the percentage difference?
Hold on. What was it? 70, is this room?
78.
Okay.
And 67.
67, all right. So this goes to today's lesson, actually.
Oh my.
So what's the difference between the temps? Justin? 11. Now, we would need to know what the actual temp is supposed to be. So I'm going to err on the side of Mrs. Goldring and say the temp is supposed to be 67. So to find that percent error or percent difference, we would just take the difference between them divided by what it's supposed to be. I lost my calculator. Last class I threw it because it's stupid. Because it's dumb. It doesn't think.
I know, right?
Hey, Adam, it's 16%. So this comes out to be 0.164. 11 divided by 67. You should get 60. Fun little application. I always love to screw with Mr. Sherg. Anytime I can.
Ooh, I did the second.
So, who can help me with the second row down? You're both about to jump out of your seats. I talked to you most recently, so Izzy?
We did this in class yesterday.
Ah, yeah, I thought we did. This, when we read it properly, reads 12 hundredths
And then it's equivalent
to 6/50ths, which can still be reduced further to 3/25ths. Now, we like our fraction to be in reduced form, but to go to decimal or to percent form, we actually like the stacked over a power of 10. So this then becomes the percent value. Finish us out. Easy. The easy way is just move your decimal 2 places to the right. And it becomes 12%. Abby, what about my next one? This one's tough. It's 175%.
Your next one is the decimal, of course, is 0.175.
Is not.
No.
Now hold up. We're,
1.7.
so, back yourself up for a second. What does percent mean? Divide by 100. So this would be 175 over 100. Which would be a mixed number. If I want to make this a proper fraction, it's 1 and 75 hundredths. Which is why when Abby corrected herself, she said it's actually 1.75. Or, read correctly, 1 and 75 hundredths. Abby, do you know our reduced fraction form then?
Try.
So what does 75 hundredths reduce down to?
It reduces down.
We could get it down to 25, but we could go further than that. One more chance. Last one.
You reduce it by 25.
What's it turn into?
3.
Oh, 3.
No, 3. 1 and 3/4.
1 and 3/4. If we divide by 25 on top and on bottom, We get 1 3/4. Our last one, Mr. Surface, you've had your hand up for a while.
Okay, so the decimal is 0.006.
How do I read that properly?
0 and 6,000.
6 thousandths. Do you want to go fraction or percent?
Well, that would be our fraction.
But we want to reduce it, right? Because I can reduce. What are these both reduced by? 2, because they're both even. So this becomes 3 500ths. Do you know what your percent form of this would be?
Well, yeah, it would be 0 and 6/10.
0 and 6/10 of a percent. Because when we multiply by 100, we shift our decimal 2 places. Any questions on this table? Please refer back to this as you're working on your practice to help you remember the techniques that we use. So now, if I have any volunteers for note passer outers, we have
Are we doing 8 now? No, we're doing 7.
percent error. Divvy up. Or, fist fight or whatever. By the way, as we get deeper into calculator work, these, the TI-30 multi-view, which please don't think about, oh, I could take one of these home. This is literally school yellow. You can't get the yellow unless you're a school. So please leave these at school. These are exactly what I have up here on the poster. These are awesome. I used to swear by the TI-30 X2S, which is this calculator. But I got introduced to the multi-view, which lets you see not only the problem you're working on, but the problem you just worked on. So it lets you see 2 problems at the same time, which is really sweet. So if you want to use these during class, they're right up here. But before I dismiss class, I got to see all 10 calculators up there. So if you need one, feel free to grab one at any point during class. But I keep them up there so that I can see who has them and who needs to put them away. The 34 is fine.
Oh wait, so this is just the exact same thing.
Maybe. Yeah, if you bought the calculator from the supply list, it's the same thing. Yeah, so if you have the one from the supply list, you have the same calculator. Yeah, yes. Yeah, or you can just borrow one of mine, whichever you want. I mean, it's quicker to just borrow one of mine. I am. I'm a little bit comfortable today. Our origami club, if you guys decide to start one, you can have an origami club, decides to hold a fundraiser. Their goal is to sell 200 origami animals in the first week. Your friend in the origami club tells you they were 3% from their goal, and we're going to go ahead and say this is an ambiguous word, it's not very specific. We're going to say they were 3% below their goal. They did not meet their goal. They were 3% below it. Here's hoping next week they have some better sales. So this is now introducing our idea of percent error, or different from what I'm shooting for. If I want 200, and I don't get that, there's a certain amount of percent error or percent gap. So Justin, if they tell you that we're 3% from the goal, how would you calculate how many animals they didn't sell?
Right, so since 200 is their 100%, and if they're 3% off, kind of confusing, but since you multiply 100 by 2, you can multiply 3 by 2, it's 6.
Yeah, so it's not that complicated. I follow your thought process. I understand how you your peers might not be following inside your head. What Justin did was broke it down to 1%. So he said 1% of 200 is 2. Because to find 1%, you just divide by 2. But we're not looking for 1%, we're looking for 3%. So he tripled it and got 6. So they are 6 origami animals below the goal. Now the other thing we could have done is do our 0.03 times the 200, and that would also give us 6. But if you can reason through it mentally, sweet. Go ahead and do that. Now the question's actually asking me, how many animals did the group sell? So if they were 6 away from their goal, how do we figure out how many animals they actually sold, Shane? Yeah, we do the difference between them. So they actually sold how many? 194 origami animals. And they did not regretfully make their goal this week. Maybe they should adjust their goal, or maybe they should advertise, or maybe they should change their price. Whatever's going on, they did not make their goal. Now, if this sort of problem excites you, Phoenix Fair is coming up. People will buy almost anything before the holiday season because they need gifts for all kinds of people. And especially like grandmas and grandpas love handmade gifts. So when you're thinking about, do I want to do Phoenix Fair or not, the question you should be asking yourself is, do I want to potentially make profit?
Yes.
And if you want to be able to make profit, start thinking about what sort of things you can do. We one year had a student, now given this was an 8th grader, he'd been through Phoenix Fair before, we had a student write a book. And there's websites you can send your book to actually get it made into a book, like a soft cover book, and he sold books at Phoenix Fair. It was sweet. It was a book he had written. Abby?
Yeah. So like, don't they call like the Phoenix like craft fair and like things?
Yeah, so it doesn't have to be crafts, but most of it probably is. So, Anthony.
When you say Phoenix Fair, are you selling things, but you get the profit, or does Phoenix?
So if you make money, you keep 90% of the profit. But if you don't make money, you don't owe us anything. But if you make profit, you just donate 10% of that to the PTSA, and essentially you're paying for your space. So anytime you go to like sell things, you'd need to like either go to a festival or something. And a lot of times there's like a registration fee. We don't charge you guys a fee. The vendors that come, like the companies that come, they get charged a fee no matter what, and then a percentage of sales. You guys, we only charge, and you do all this math like in social studies, and we might block up to do the class. But that was why we definitely wanted to talk about percents before you guys got to Phoenix Fair, is you will donate 10% of your profit. So only money made. So if you made $20 profit, you just give $2 to the PTSA to thank them for, renting the space. Then we'll cut your penny into 100 pieces. If you have not heard my story about Sonic, ask me about that at some point. There's an ad, I think I saw the ad up there. There was an ad misprinted, and the math was very funny. So you need to circle, star, highlight something to notate that percent error, our formula right here, is essentially exactly like our normal percent formula. The only difference is that the part we're looking for is the amount of difference. It has to be positive. Hence, we use, what are these bars called? Absolute value. Now, who can remember not what it does? What is absolute value actually asking us? Absolute value is kind of asking a question. Abby? So that's what it does. It makes it positive because absolute value is actually asking for the distance away from 0.
Oh yeah.
So you need to remember what it does is makes things positive. But what it's asking, the actual math behind it, is how far are you from 0? Distances have to be positive. So our friend gets on the bus and she quickly says, I think there's about 36 passengers. She then sits down and she's bored, so she counts and figures out, there's actually 45 passengers. So she's really bored, so she decides to calculate her percent error. And her percent error then, the amount of error, which is what I'm going to put on the top here if you want to make yourself a little note, really on top is just the amount of error. So her amount of error was really 9. It doesn't matter if you're above the actual or below the actual. Her error was 9, and there are actually 45 people. So we do 9 divided by 45. They could both be divided by 9, and we would actually get very close to 2/10. Actually, we'd get exactly 2/10 because this would reduce to 1/5, which would then become 2/10, or 0.2, or 20%.
Pardon the interruption. Lainey Reynolds, please come to the office. Lainey Reynolds to the office, please.
So what this is actually saying is her guess is off by 20%. And we could take that a little bit further and say her guess is 20% below the actual. If you wanted to be specific about the fact that it is lower than the real. Any questions with finding the amount of error for the numerator or the fact that we have to divide by the actual amount? Now, let's take an example. What if we had, instead of dividing by the actual amount, what if we had divided by her guess? So if I had 9 divided by 36, that would actually come out to be 25%, which is different. So you've got to be careful, guys. The most mistakes I see come from the wrong denominator. You've got to have the real value or the actual in the denominator. So I will tell you, you guys are lucky because the Accelerated 7 class always hits the homeworks before you do. So they ask me the questions and I know what questions they have. There's a question on the homework for percent error dealing with a town's population. And they expected the population to increase from one amount to another amount. And then it actually increased from the amount where it started to a lower amount. What you're actually looking at with that problem, did you already solve this one? Do you want to? Okay. So do you have anything to say about it? That problem, you're comparing the expected increase, not the amount of population, but the expected increase with what the actual increase was. It's tricky because you don't need the actual numbers in the problem. The population amount itself doesn't matter. You're looking at the change in population. If you hit that problem and you struggle, come see me. I'll know exactly what you're struggling on. So try these on your own. We want to remember that to find percent error, it's the amount of error or the difference over the actual. So try these on your own. Huh? Round to the nearest percent. Sorry, it says that in the directions. So if it is repeating, round it. Round to that nearest percent. The amount of error, like the difference between them, divided by the actual amount, like the real thing. I know. Fancy schmancy. Question or answer? That's not the amount of error. So if they estimated 40 and they actually had 45, what's the amount of error is the difference between them? Yes, your numerator would actually be 5 and your denominator would be 45. So CJ, on our first problem there where they estimated 40 and the actual amount was 45, how'd you find the numerator? That's okay. Do you want to try to work it through or you want to pass it? Grace?
I did the same thing we did in the first one, the bus. I did
So up here, it said measured or estimated minus actual. Now, why did you do 45 minus 40? Because it's right, but why'd you do it that way? It's easier, right? Because the absolute value, the order of your subtraction doesn't matter. So you have to have a positive answer. My advice for your numerator, always do big minus small. So Grace did 45 minus 40 for the numerator to find the amount of error divided by what was the actual? 45. This comes out to be 5 over 45, which could reduce to, 1/9, which comes out to be repeating. So that'd be 0.11111 forever. But when I round that to the nearest, we just get 11%. Because, remember, to go to percent form, we multiply by 100, which moves your decimal 2 places, and we end up with 11.1 forever. But when we round, that 0.1 forever drops off. As long as you make it positive, yes, it does not matter. Because if I did 40 minus 45, I'd get -5, but there's really an absolute value around this. I just didn't draw it because we didn't need it in this problem because we set it up in a way that my answer would be positive. So, Xavier, for my next one, how do you do that?
So the amount of error was 12.
Yeah, so sometimes we can just look at it. We can say, okay, the amount of error here is 12. It'll come back in a second.
And the actual value was 75.
So we take 12 on top, 75 on bottom. We can reduce these, actually.
6.
Ooh, that's tough. Think about, what can I divide 12 by? I could divide by 3, 4, or 6, right? So think about 3, 4, or 6. 3 would be easy down here. So if I divide by 3, this becomes 4 25ths. Then, make it get over 100. How do I do that? Multiply by 4, so this becomes 16 hundredths, or 16%. So we get 16% error there. Miss Benson. Did she disappear? Oh, hasta luego. We'll get you when you come back. You're going back in the stack. I got very confused. I was like, there's some of you that I mix up, but I got pretty much everybody now. Miss Benkowski. Love your last name. What's the error in my third one here? Between 125 and 99. We are not going to calculate this. We're going to approximate this. What is 99 approximately? If you round it, if you let it just be close. 100. So if it was 100, it'd be 25. It's 99, so we see it's 26. We put that over the actual, which is 99. So if I wanted to really calculate this, it would repeat the numerator, because my denominator is 9s. So this would be 0.26 forever, repeating. But that, especially when we round it, just becomes 26%. We do not even need to touch a calculator. Any questions on those three? I've got the 2 still up on the TV and the third one down here. Izzy? Yeah, your percent has to be positive. So you can't have a negative percent value, just like you can't have a negative distance. But you could say my estimate, like on B here, we would say our estimate was 16% below the actual. So we wouldn't say a negative 16%. We would just say 16% below. Or above, like in part C, we'd say our estimate was 26% higher than the actual. Other preguntas? All right, let's move on. Try the goddess. Es un bueno.
I don't speak Spanish.
Bueno tienda, I think is time. It's fun to speak
What
Spanish.
is everything you just said?
Diez y... telling the minutes is always hard. Diez y veinte y tres?
Single.
5. It's not 5.
I'm looking at smartboard time.
It's 10:25.
Smartboard time.
Yeah.
Oh, 10:25. Yeah, no, that. Phoenix is a couple minutes slower than the rest of the world. By the way, time doesn't exist. Just if you want to really have a thought to float around your mind, we invented time.
It's just a way to
Yeah, it's just a measurement that we've invented. So, time is really kind of this relative construct. I agree. So somebody put that on Facebook, which then proceeded to make this larger discussion of, and I actually brought this up, well, math is also just invented. But it's how we make sense of the world around us. So math didn't exist before there were people to think about the math. But did mathematical relationships exist before we observed them? Now we're going to write a paper later in the year about this. It's an opinion paper, so there's no like right or wrong answer. But that is one of the big questions that people kind of like to grapple with. It's like the chicken or the egg. Did it exist before we were here, or did we have to exist for it to exist? So if we come back to the got it. Do you have a question? Sorry.
No, I was just gonna say it kind of bothers me to think that someone actually like thought of math, like how did they come up with math?
So I'm gonna put up. The folder might actually be on Schoology already. I've got a folder of material called like Math. What a Weird Idea. Anyone have any idea if it's on our Schoology? If not, I'll make it live. So for a very odd look at all right, Merry Christmas. This is totally optional for the time being. But this is what, and don't freak out about the paper. This is not the same directions as your paper. But if you're curious about like the origins of numbers, check out this folder. It's got a few videos in it that kind of in a humorous manner go through where numbers came from and like how they were invented. So at the very bottom of the Accelerated 7 page, I've now made this live. So this whole idea of where did numbers come from. So I've got a couple videos in here. And so this is, Numberphile is great. If you're interested in math and you kind of like watching YouTube videos, Numberphile is a great YouTube handle to follow. He's got awesome, like he interviews mathematicians and he like poses all these interesting math problems. So check out that stuff if you're curious. The first video in there is really funny. Anthony, then this question's yours because your card is up next.
I figured out which came first, the chicken or the egg.
What? The check. So, Anthony, if we were looking at this got it, what is the division that you set up?
You do the difference between the estimated value and the actual.
Yeah, what is that difference? And what goes in the denominator?
200.
Exactly. We can reduce this to a form that's easy for us to use. What would that be? Ooh, no, that's too far. We don't always want to go to simplest. Since we're looking for percent, it's easier if we end up with what in the denominator? Shane? 100, or a 10, or 1,000, or some power of 100. So I could either make this a 10 or 100. Now, to begin with, right here, I can chop off stacked zeros. Anytime you have division, and there are zeros stacked at the end of the numbers, you can chop them off. So this is really 5/20ths. So can the 20 become a 10 and have the 5 do the same thing? No, because we'd have to divide them by 2. So can the 20 become 100? Yes. What do we do? Times 5. Or you would have divided by 2 if that's where you started. And you end up with 25 hundredths. What is that as a decimal, Anthony? As a decimal, Anthony. Yeah, it's 25 hundredths, which as a percent, anybody? 25%. Yeah.
Multiplied up to 1,000.
Yeah, so if you started with 50 over 200, you could have also said, let's make this 1,000, so you multiplied by 5, and made this 250, which becomes 250 thousandths, which is still the same thing. So perfectly fine. Lots of right ways to get to Florida. What? I'm always interested in what you guys are saying. I don't say what because you're in trouble. I say what because I want to know. Javier! All right. We have Jay, Sarah, Lisa, and the only person with a cool name, Javier. And sorry, I don't think any of us have those names, but these are all like very common old names, and then we just have one Javier.
Oh, I know Javier.
So, I run a contest, and we're going to do this here probably in a week or two, because we have to get through percent error before I can do this contest. I bring in a mason jar, a small one, and I fill it with Skittles. I do not count how many are in it. All the way, as many Skittles as it can fit in. You cannot open it, you cannot, you can pick it up, you can look at it, that's about all you can do. If you choose, you can make an estimate to how many Skittles are in the jar. Now, I run my competition. Whoever's closest wins. If two people tie as closest, you can both win, and I'll get another jar. But the winner gets the jar full of Skittles. Now, this teacher is nicer than me. He's going to allow anybody to win, or as many people to win, as are within 5% of the actual number. So we want to figure out what the amount of error for each of them is when we know that there are actually 486 jelly beans in the jar. Well, this one's jelly beans, but on my jar is smaller, so there will not be 400. My apologies. So, who can walk me through how to find J's percent error? Is that a hand or no? Because I've talked to Izzy a bunch, so if you've got your hand up, I'd love to chat with you. Otherwise, I'm going to cards. Go to cards. Miss Suddendorf, how do I find out the amount of error, or what needs to go in the numerator for J? Not yet. The first thing we want to do is figure... Now, still not yet. The first thing we want to do is calculate the amount of error, or how far the guess is off. So if J guessed 450, and the actual is 486, how far away is the guess from the actual? How do you find difference? What mathematical operation? You subtract, right? So I take, and by the way, we're not sorting winners and losers yet, so you need to do this work like somewhere either down at the bottom or off to the side. We would do 486 minus 450 over the actual, be careful, 486. So this comes out to be 36 over 486. Now we convert it to a decimal by doing the division. We get 0.074. Yeah, there's a 0 after that.
0.7.
I'm going to round and just drop a 1 there, because it would be 0.7, so I'm just going to round it. Then to convert to the decimal, we multiply by the 100, and our decimal value becomes... Yeah, so when I do like this, by the way, it's anybody. That's like a shout out, whatever. So J ends up with a 7 point, well, I might as well keep using red, ends up with a 7.4% error. Is J a winner or a loser? Jay's a loser. So, hold up. We have about 90 seconds left. I bet you can't finish all three of these. Quitter.
Javier won.
That's not the same guy that I saw get that sack.
That's not
I'm pretty tired.
Javier.
Wait.
No, I barely played.
I have not been able to come see you guys in a while because I've had too much going on. I'm coming, yeah. That's next week? I don't really, well, we have a couple conferences scheduled, but I'll see if I can get out of them. If I have to go take pictures, they might let me not come
You
to
should
these
come to
conferences.
ours. You haven't been to
Any of you guys that are working hard? Anyone figure out Sarah's error yet?
Sarah's probably.
Shane? Yeah, so you went all the way through and did all the work? 20.2%. Lisa seems closer. Julia?
Should I like say the steps? Because I haven't like figured it all out.
So yeah, go ahead and walk through.
So you would do 475.
So you can do the subtraction either way.
I actually want to do. It would be 486 minus
Uh-huh.
475.
Which comes out with a difference of 11.
And then yeah.
Did you get the percent yet?
No.
So, Lisa ends up with approximately a 2.2% error. And Javier, for what it's worth, just make sure that you know how to solve these. If you can't get these answers, you need to come work with me at AL. Javier ends up with 3.08% error. So, Lisa and Javier are both winners. Alright guys, get on out of here. Your homework is already up. Please get your homework done so you can take the mastery tomorrow. Are you playing tonight?